This is episode 15. This is the 15th time we've streamed programming for an NES game live on Twitch, and we're continuing our work on the asset tool. Now that we have the ability to take a PNG that we've loaded, determine the number of colors used by that PNG, create the 4-color palette that's necessary for that content, and can export the sprite as a binary file that we will hopefully be able to use in some capacity to export to the NES. We showed how I was able to take the content from this and export it so that the shooter application, the shooter game, can export the tiles, and we even exported the palette to the NES game so that we could see what the what that would look like. That's all looking good. So we have that basic functionality working here, and what I want to do next is I want to build on this and allow for a couple of things. One is I probably want to start by allowing us to change some colors in the image. I also would like to be able to draw the bounding box, and in the last episode I was debating whether or not we would want to have more than one bounding box for each sprite, but thinking about it, way back in the beginning, I had talked about the possibility of, we might have some sort of enemy ship that is a, large sort of multi-wing. This looks like looks like a Batman type vehicle or whatever. But the point is, it's got multiple different shapes, and you would have potentially the need to have multiple bounding boxes that are applicable for that shape. So I think we may have to go back and change the file format for sprites a little bit to accommodate for the bounding box information. And then once we've gotten that sorted out, we can go through the process of actually adding the bounding boxes and manipulating them, and then starting to get that into the NES game, starting with the flyby, which is our simplest case, where we just have a standard rectangular box. I think I probably want to do the same thing with our bullet. Right now the bullet is just a 3-point of collision. Essentially, we had created these collision points that we were loading or storing here in the assembly. It would be good to make that be something that we build in the tool, and let's we'll start with the flyby, because that's actually going to be the easier one to change. Right now, the flyby, we're just manually checking the bounding box against hard-coded data. So let's see, we're checking the bullet collision here. So if we look at this subroutine, we are, so if it's a flyby, we're doing the comparison just basically by adding 8 around, because we know that it's 8 by 8. It'd be better to load that information from the data in the collisions. We have some sort of collision table lookup that we could use to determine the collision information rather than hard coding it, and potentially even, like I said, support multiple bounding boxes, although the flyby itself would only have the one. So let's get started with that. So in order to do that, we need to go back and change our sprite structure, because right now it's hard coding the bounding box information into an array of 8 is it 8? Yeah, 8 vector, or no, 4 vector 2s. And a vector 2 is just these short x and y values, so it's 2 bytes. Probably I want to change that actually to be character. Well, you know, for the purposes of this, let's leave it short. Eventually, we will have to. So right now, the code that we've written on the NES side only supports single byte comparison. We will need to allow for the multi-byte 16-bit comparison if we want to do anything that actually represents this in 2 bytes. But for now, we can convert this and add some sort of check that, you know, gives an error if we are in the process of trying to use a 16-bit value that wouldn't be properly checked. So what we do need to change here, though, is that we have, for the bounding boxes, we have a single one in here. I want to change this to be number of bounding boxes. And then I'm going to remove this because that's going to be similarly stored here. Like with the image, we're going to have vector 2 array of, do you want to do pointers? I guess we just do pointer of pointers for bounding boxes. Right, because we have to allocate enough size for a bounding for the 4 bounding points that we need, the 4 vector 2s, and then we would have potentially an array of those. All right. So this obviously has to change now. And the first thing we need to do is get a pointer to the array of vector 2s, right? And if we were going to have more than one bounding box, this would obviously change. But for now, bounding box size, right? And this is just a casting problem. And probably what I want to do is, just to make this a little bit more straightforward, we'll say vector 2 current box equals new sprite bounding boxes, right? And again, because this is just the one, this just gets changed. Oh, yeah, this is. All right, so now when we write this, what we need to do is we need to write what did I do? It's been a long day. I think I may have done this the wrong way. Let's see. So we've got our array of vector pointers. I actually probably, let me think about this for a second. Maybe it's better, instead of doing the array of vector pointers, I think it might actually be better for us to do just the one pointer and allocate simply enough space to support the bounding box size. And if you were to have multiple bounding boxes, you just index, you know, for the third set of bounding boxes, you'd multiply times 3 or 4 or whatever the case may be. And then that's actually easier to handle. And again, this so kind of undoes the change that I just did, because the only reason I like this better is because now we're basically just going to have a single blob of bounding box information rather than a bunch of bounding box information that we have to kind of piece together as different arrays of these vector2s. It'll make it easier to write to the file and read from the file and stuff like that. So, so I want to write new sprite bounding boxes. That usually helps. And also spelling it right helps. So I'm writing that memory, and that's size of vector2 times the bounding box size times new sprite number of bounding boxes. I should probably set that to 1. All right, so that'll write the information, and if we rerun that and take a look at our sprite that gets generated, let's open up the hex editor. If we look, we've got our image data that's going to be written to the end of the file, and then we have our sprite. Let's do it. Well, it doesn't matter for this character. We know it's what was it, 16 by 32. So the sprite structure has a version byte, which probably should set to 1, but that's fine for now. I'll change it in a minute. It's not a version byte; it's a version short. We've got the name of the sprite, or the image rather, that it came from. There are 256 bytes of that. The 256 bits are not completely initialized to 0 because of the way that Visual Studio in debug mode writes all of this information for you to know that it was not intentionally set to anything, that it was actually the debugger code that was doing that. It helps you detect things like out of bounds and whatnot. So then we get the palette that was written, right? Those 4 bytes here, and then the width, which is 16, the height, which is 32. And I can see that over here, like we said last time. And then we have the number of bounding boxes, which is just 1. And then we have our 256 bytes of padding for anything else we might add in the future. And then we have our data, our image data, which is going to be 16 by 32, so it's going to be 512 bytes. So we should see 512 did I mess that up somewhere? Unsigned character size times image width times image height. So it's writing that, which is just a character. Image width, image height is the size. The problem. Let's see. Let's recreate the sprite. So the width is 16, the height is 32. So unless I'm just not able to operate 512 bytes, right? So after the 256 bytes, now we're going to have 512 bytes. Right, and then it should just be the bounding boxes after that. So what gives? Oh, well, that's not exactly true. So it's going to be, let's see, we're going to get that. I forgot, we get 2 pointers before we get our 256 bytes. So there's that image, number of bounding boxes, then 4 bytes, another 4 bytes, and then our 256. No, I reversed that. Scratch that. 256. Right, and then 4 bytes, and then 4 bytes, and then our image data, which is 512 bytes. Which that's weird because there doesn't seem like the data is there. It seems like the data is following and not being written according to what I expected to see. Can I tell this to reload partially? Just reopen that. Interesting. So size of new sprite. So that's the whole new sprite structure. That's the index data. That's the size of character times width times height. So that should just be 512. Is my buffer somehow? Well, I just wrote unsigned, so who knows what that's going to be. That should be an unsigned character so that it's actually 8 bits, a byte. That would be helpful. Let's try that again. Create sprite. Just run it and see what happens when we reload it. Hey, it's much shorter. Okay, so that was our bounding box count, and then we had our two pointers, and then we have 512. No, sorry, 256 bytes. Keep doing it out of order. It doesn't matter really because the information in there isn't meaningful at the moment. It's actually 256 bytes plus then the 2 pointers. Oh, but the bounding boxes has, okay, so that's fine. The more important thing is that we're actually seeing real data. Let me go back here for a second. So that's one bounding box count. Then we have our 256, right? And then we have one pointer, we have another pointer, and then we have 512 bytes of data, which is our indexed data for the image. And then we should have our bounding boxes, which I feel like I'm just off by a byte. But anyway, that looks... I'm going to make this aligned so that it's better byte aligned. Let's start this over again. Written. that's the file. Let me reopen this. Okay, so let's go back through this again. So that was the end of our file name, and we have width. No, we have our palette 4 bytes. We have our width. We have our height. Then we have our number of bounding boxes, which I've which I've made a unsigned int. This is very strange. Why am I having such a hard time? I'm tired. That's not helping things, but this should be relatively straightforward, and I'm messing it up. So that's the file name, 256 bytes. Right? Yeah. And then, oh, really? The 255 bytes or it's 256 bytes. So, yeah. I don't know why I'm having these issues right now. Palette. Here's the width, which is 16. Here's the height, which is 32. And then, is this because of endianness? It shouldn't be, because it should be binary mode. It's a little endian, so what gives? Where are we off by here? That one, I wonder. I wonder if the compiler is padding, because I remember hearing somewhere that the compiler will try and pad the data structure. I mean, that's what it seems like it's doing, because this value here should be the number of bounding boxes, and then we should have our 256 bytes. Right? That's our 256 bytes. Then we have our image pointer, which is null. This pointer should be null, but that's okay. That's just the pointer to the bounding boxes array, which is meaningless in this context. In the file, then we have our 512 bytes for the image. And then we have our bounding values. So X and Y and X and Y. Yeah, so that all looks fine. I think it is doing some sort of padding with this, because let's see, so that would be 2 bytes, and then that's 256 bytes, so now it's not 4 byte aligned after these 4 bytes. Is that what the problem is? Right, 2 plus 256 is 258, plus 4 is 262. Is it really trying to do that? Well, the easy way to find out would be to I don't know. I don't know that I care right now, just because it's not going to impact anything we're doing on the NES at this point. Well, I do care, because any structures we want to write out now, we got to make sure that they're properly aligned for the NES, because it's going to care. Struct byte alignment. Wish MSDN would just search its own stuff. Site msdn.microsoft.com struct alignment. Hey, look at that. Google can search it better than Microsoft can. Applications should generally align structure members to, yeah. By boundaries, even boundaries. Compiler automatically aligns data in accordance with these requirements, inserting padding. So it does. Let's see. The default pack size is 2, whereas the default for Windows 32 is 8. As a consequence, you may not get alignment, different default size. I thought there was a way. To force it to align the data however you wanted. Pack structures, so you could do ZP1. Unaligned. Do you do that? Where do you do that? You do that in there. And again, I mean, on the one hand, you could argue, well, you know, you want the alignment to be properly done, but I don't necessarily like the compiler doing it for me, because then I got to make sure. I guess it doesn't matter. Well, anyway, so yes, it's possible to change the byte alignment of the compiler. Let's go back and change our structure to handle this a little bit more. I don't know what's the right word. Gracefully or deliberately, so that we don't run into weird behavior if we haven't examined this carefully enough in moving forward in the future. So let's see. So we've got. So it wants 8-byte alignment, huh? That's weird. I mean, I know why, but I'm not sure why it's doing that for this int, where I guess if I change it to a short, would it do the same thing? Let's see what we get here. So that's our one bounding box count, and then looks like looks like we don't get any padding bytes here, because that's 256. That's our 2 pointers, and then this is our 512, and then yeah, and then we get our bounding box of data at the end. We'll leave it that way. We really don't need it to be an unsigned int, because we're not going to have that many bounding boxes. Let's see. So that's working now better. I'm going to change the version to 1. For this, I need a temporary to hold the bounding boxes. Because I need to write it, and I don't have it anywhere else. Okay, and then I'm going to null it out because it's meaningless here. And then once that's done, I guess we want to free that. So free new bounding boxes, right? And then free new sprite, because we're not using that here. We're going to use it once we. Oh, it's not a. Okay, I forgot from last time that wasn't an allocated value. Okay, so that's should all still be good. And I closed this, but I didn't want to. cursory glance, that looks still wrong. Why? Why is that pointer still... Well, we'll know in a second if I do this copy here, or this selection. Is that 250? 256 bytes? 6 bytes. 1, 2. Why is that pointer still... Bounding boxes? No. Is it not overwriting the file? Should be. Buffers. Oh! Yeah. We gotta use that one now instead of the sprite one. Sorry, I'm just kind of tired today and making some silly mistakes. Feeling slow today. Alright, so new sprite, number of bounding boxes. Bounding boxes. That is the pointer to this. That has that data. That's null. Should be writing that out. So that's the number of bounding boxes as we saw before. We got 256 bytes. Then we get 2 pointers. Then we get 500. Oops. We get 512 bytes. And our bounding box data is gone. Oh, Lord. What did I do? Bounding box size, number of bounding boxes. That's no. Free bounding boxes. Create sprite. Yeah. Use sprite. It's 1, and then right. Yeah. That looks good. So what gives? What gives Visual Studio? What did I... Oh, it's there now. Did I just open it at the wrong time and it didn't have the data in it? I don't know. Maybe I should keep this as a short stream. All right, so we've got that sprite. So now what I want to do is when you select the sprite here, right now it's assuming that it's an image. What we need to do is we need to check to see if it is in fact an image, and if it is not, then we will return, we will load the sprite information and the sprite editor. So I'm just going to write a little helper routine here in case there are some other things we want to do to check if it's a sprite. Otherwise, else if is image. I mean, I think I'm pretty satisfied with that as a way of checking, and then the only reason I'm breaking this out is because although right now my only criteria is to look and see if it is a PNG file or a .sprite file, but moving forward in the future, might decide that there are some other criteria, like we want to check to see ahead of time, is the image an indexed PNG, or is it just a standard PNG that has RGB colors or stuff like that, which we wouldn't support and would give us problems. But for now, this is good enough. Even simpler, we say if we just say return check extension sprite, right? I mean, really super simple here. In fact, I think we, no, it wasn't here, it was in this. That was getting the file extension and doing the string comparison, right? Less than size of supported extension. Oh, right, yeah, we were just comparing the extensions here, so that's not really getting the extension. It's simple enough. So, all right. Let's move this. Let's move this. This isn't Windows 32 specifically. That in the copy paste buffer. Let's put that there. Save that. Add. So that's our helpers. Get file extension. This here too. Okay, so and then the final thing is we gotta, obviously we gotta pass the, oops. Man, I'm just feeling out of it today. It's a tough thing about doing a stream on a schedule rather than when you feel like it. It's just kind of, some days maybe not the best day to stream, but I really want to stay consistent on working on this at least twice a week live. Let's see here. So now I should be able to call that helper function, right? Which was get file extension. So get file extension, extension. It's just whatever it is. 10 file name extension. If not, string compare. I guess we should do. Does Microsoft support this one? No. we'll do case insensitive comparison for this. So if the comparison is, let's see, we've got the extension. Oh, I've already called it this. So file ext and extension. Actually, I can just return. Let's see. Check so I wanted to return this, basically. So just return the comparison of the case insensitive comparison of the extension versus what was used, passed in rather. Do I have to use that one? What is it? What is it? String compare. Oh, underscore string I compare. Helps if you read the entire error message. Yeah. So that's that. That compiled, and then we can do this. Just add a little. So it shouldn't do the normal stuff that it does. So if I click on that, I broke it. Okay. Current file list name is sprite. So when I pass it to is sprite, file name, sprite extension. Did I inconsistently use the dot? Yeah, I did. I inconsistently didn't. Okay. So I just got to use the period in the extension, and that'll resolve that. So if I click on the PNG, okay, cool. Click on that, we get this is a sprite. Okay, cool. Rolls Warren, you seem to be a good developer. Can you write a modern OpenGL game? Yeah, I mean, I can, but the problem with writing a modern game using something like OpenGL, beyond just the complexity of using something like OpenGL and vertex and pixel shaders, is that you need assets to to go with your modern OpenGL game. So you have to either have 3D models, or you have to have higher quality graphics than what you would require on the NES. And the game is expected to be a heck of a lot more complex than what an NES game is. So while sure, yeah, I could, and I've done some stuff, and I'll do a stream one of these days soon where I show some other projects that I've worked on, including a game that's a fully 3D game that does use vertex and pixel shaders for things like real-time lighting, very sparingly, because the game was made from the 3D perspective without any actual 3D artists. So while I can do that, and I don't have any issue understanding what's required to do that, making a game for the NES is way more straightforward, and it's something I can do by myself or with, minimal artwork required, and the expectation on the length and complexity of the game is certainly a lot less, being that it's an actual NES game that runs on the same system that was released in whatever it was, 1986 here, or whatever it was. So that's why I'm doing that. If you want to see someone building an actual full production quality game from scratch on a modern platform like OpenGL, or to that extent, like I've said in the past, go see Handmade Hero. Casey Muratori is awesome programmer. He's been doing this for forever. He's been streaming his episodes on weekends. They've gotten pretty long, but they're like 3 hours on Saturdays and Sundays, and he just goes through. You can watch the back catalog on YouTube, but he goes through, the steps of starting with the game, loading the assets, getting them working to some degree, then switching over to OpenGL for rendering speed, and progressing there. And he has the benefit of having assets that he's gotten for this game that he's building. I don't have that right now. And plus, I also really, really wanted to make something for the NES, just because growing up as a kid, that was my first real video game experience where I was excited about it. I had an Atari 2600, and while, I had games for it, it was not something, just because of the games themselves, for some reason, it didn't really have the same level of excitement to me as the NES did. I mean, playing Legend of Zelda really just was like mind-blowing to me, and that game, along with some other games, were the reason why I even wanted to learn how to write software in the first place. So from there I started learning on my own, and then eventually taking classes too. So hopefully that answers your question. All right, so we've got a sprite. It knows that it's a sprite now. So, okay, let's switch over. Yeah, you got to. It's funny. The chat is a little bit behind the stream, so I saw your comments popping up as I was talking. Zelda is definitely my absolute favorite series of games. Couldn't tell you why. They just are, and so, I think it stems from the first game. All right, so let's go back to our code here. So now that we have it detecting if it's a sprite or if it is a just a PNG, what we want to do, I think we need to maybe restructure this a little bit. Because part of the challenge of the way that we've built this is because we're building the UI components themselves as we build the functionality of the tools itself, is that it's kind of a combination of code that's testing out the UI functionality as well as then also trying to make things happen with the game. All right. Trying to think about how I want to do this. So this normally loads the image from this location. What I need to do is I need to, when we have this, I want to load, I guess, the sprite. So let's do this. Let's yeah, making your own engine is very time consuming. And learning C++ is certainly good for it because it's going to be pretty important to getting it to be super efficient. Realistically, not any of the actual C++ stuff, like the object-oriented sides of things, because although from a development perspective, writing code with object-oriented design is certainly easier. Like writing code that's object-oriented can be a lot faster, for you as a programmer, but in terms of the code that it creates, it's definitely not as fast as writing, pretty much straight up C. And a lot of times you end up building things as objects and classes that don't necessarily need to be. Like I can see, in here we could do all of this stuff as classes, but honestly, a lot of what I'm trying to do, the classes are just going to be organizational things. And so basically I just put all of that stuff into a namespace, right? Just so that it's kind of isolated into that namespace that we've created here. We've got our structs and, our functions, and yeah, the functions could be members of a class, but realistically, they would probably be static functions, just because of the way that this UI works. So, yeah, I'm not bashing OOP. I certainly use it enough in my day job, and there's, benefits to using it certainly, but it's not for game development. Some places use it, some places don't. If you've never looked at, there's a pretty, what's his name? Oh, so there's a really good YouTube video on data-driven design versus object-oriented programming and that kind of stuff. This developer, Mike Acton, he gives at I think it's the C++ conference. I don't remember the exact details, but it's a really, really good video on him explaining what drives them to write their software in a certain way that's really super efficient, that has nothing to do with object-oriented programming. And frankly, their take on it is that most of the stuff that C++ puts into the language is pretty useless from a performance and game development standpoint, because it doesn't really focus on how data is oriented and how your application uses the data. It's just kind of adding bells and whistles to the language. Anyway, I'm paraphrasing. You should go watch the video. It's really, really good. He really presents some excellent points, and then there's a Q&A at the end, which is pretty interesting too. All right, so let's see. Let's load our sprite here. And I guess we should probably load it into the data structure that we've got here. And obviously we don't have anything called load sprite. Let's fix that. Load sprite. We're going to make it take the sprite as a parameter. And what I want to just do is check the bounding boxes and free them, because I'm going to assume that this is coming in from a previous call where it may have been used already. And we want to reallocate that. There's the image is, so the image, let's see. Why? Oh, I see. So I made it a pointer there. Okay. Okay. Sorry. I'm piecing back what I did in my mind, since it seems like Thursday was so long ago. Rules Warren, when we get to the end of the stream, let me know if you're still on, and we can talk about your sharing classes problem. I want to see if I can get through this. I've been streaming an hour already, and I feel like I hardly got anything done. All right, so same thing we've been doing. We're going to open the file. We need our file. Now here we're going to do read only, and we're going to say that we're opening it as binary. And then for our sharing, we're not denying anything. And then for our mode, and all of this stuff is actually Windows specific, as I recall, and not probably good for us to be putting in here, but I don't want to worry about it too much, just because you can spend the whole stream going back and forth between platforms to try and make something properly cross-platform. So if the file descriptor is greater than or equal to 0, let's make that -1. Then we want to read from the file into our sprite, size of sprite. So that's going to read, so the important thing to remember with this is that that's only going to read the non-pointer members of the sprite. So all of this stuff here is going to be read in. And then this stuff here, we're going to get two 4-byte values, which will be 0 because those are expected to be pointers that we allocate later. What's important is that after the structural data that we read in, or I shouldn't say structural, yeah, I guess that I mean it technically is, but after we read in the sprite structure itself, we're going to get our image data, and we're going to get our bounding box data. So the first thing we need to do is we need to read in, well, actually, we need to allocate a buffer for our image data. So let's do that. So we'll allocate size of character times, now we have the width and the height because we read that in the first read. And if you've never done this in languages or any language, this read operation essentially moves an index in the file. So if you read, let's say you read 1 byte, the next byte you read, because of the way that this works, it's not reading the same byte over and over. You don't have to tell it which one you want. It's actually incremented an index in the file to the next byte, and then after that it does it again, or however many bytes you read in the read operation. So once we've read this sprite structure, that index is moved to the next portion of the data that we wrote over here, not over there, over here, which is our image data. So we want to allocate a buffer for that. We want to mem set it so that it is 0, just in case. Well, we're reading it. I mean, technically we should be mem setting it because honestly, it's like, it's the right thing to do to make it 0 so that it's clean. But at the same point, we're going to be reading in the same number of bytes, so technically, let's do this. Let's do this. Let's mem set it to a value that we know we wouldn't be getting from the NES. Let's mem set it to FF because we're not going to get 256 colors, right? So by doing this, we are going to have a way of knowing that we've maybe not read in all the data we should have. This is just a precaution, just in case something happens where the calculation gets messed up. We should be seeing that the FF and being like, wait a minute, that doesn't make sense. That should never happen. So we're read image data, and I keep recalculating this. We shouldn't need to. Size is size of sprite width, sprite height. Right, so now we've read in our data here for the image, which means we should also be doing come on, brain. Work with me right now. Okay, we've read that in. And now we need to read bounding box data in. Well, let's do this first. We have our sprite, image. Right, so that's our image data. And let's just separate this here so that we have some consistency. And then for the bounding boxes, we say bounding boxes, same thing. We're going to malloc the size of vector2 times sprite number of bounding boxes. So that's our number of bounding boxes, times bounding box size, right? And we gotta cast that. And then same thing here. I guess we should probably do the same thing here. How did I change? What? Did I change my windows into black and white mode? How did I didn't even know that was a thing you could do. Switch windows to monochrome. How? I didn't even know you could do that. How do you do that? Windows Control C. Really? Wow. Why would you make that the shortcut for? Why would that be on by default? Well, there you go. You learned something else if you didn't learn anything from my programming. Control Windows key C switches to grayscale mode. All right. Well, that was weird. Okay, so where was I before I was interrupted? So I want to do the size of that. Size is equal to this. Size is equal to this. So we read that. I also want to do that same mem set just in case. And then the all-important close, so we don't leak file handles. And that should be it. That should be reading in our information about the sprite when we click on it. So let's set a breakpoint and make sure that that is working as expected. So I click on the sprite, and let's take a look. So we have version, we have our PNG, we have our palette, which has, let's take a look at those values. Those values look correct. So that's cool. We have our width and height, we have our number of bounding boxes, we have our reserved data, we have our image data, and we have our bounding boxes, which we did not set in the sprite structure. Okay. So sprite bounding boxes equals bounding boxes. All right, so that was a minor thing. That's not that big a deal. Hopefully that should be it. Click on that, and we have a pointer. And if I drag it up there, yeah, that all looks reasonable. We're getting 16s and 32s, so that's good. Okay. So now we need to actually handle drawing that properly, right? So we have, if image is selected and the image isn't null, so if sprite selected and we can even do current sprite version doesn't equal 0, right? Because it shouldn't equal 0. It should be, it'll say greater than equal to 0. So if it's 0, we know it's not a good sprite. I mean, it's not a definitive test by any means, but we may want to move these into maybe some sort of structure that holds state for this thing, but I'm okay with not doing that right now. So, all right. So here, interesting. So, sorry. The hesitation on my part here is now we have the indexed image. We don't have the actual. We don't have an image that Tiger will display. So we got to convert that, and I knew that, but I was thinking about how we would want to handle that. I think maybe what I'll do is I'll just put it into the image pointer that we have here. So we say image is Tiger bitmap, right? And it's current sprite width, current sprite height. And we're going to draw that at a scaled, right? So we can do that with our image GUI control, but we want to load this in directly. So what I need to do is now I need to directly manipulate the image. So I want to do a I can just do a single linear index. So is that total bytes something that's outside? I don't think it is. It's not. So we'll just say int total bytes is equal to current sprite width times current sprite times height. Oops. Right. So what I'm going to do now is I'm going to be iterating over the index bytes that came in from the sprite file that are palletized for the 4-byte palette that was stored off when we created the sprite file. And I need to grab the RGB values and store that into the Tiger image. So int I is less than total bytes plus I. And then I say image pix I equals current sprite palette current sprite can't spell current sprite image total bytes. So that's really sort of a, isn't that a Tiger pixel? It is. Current, oh, so this is the, wow, that's kind of ugly. So this, I mean, it's ugly, but it's not super terrible. It's just, I wasn't expecting it to be quite that long. So you've got the current total byte, well, that's wrong. So that's the index, right? So you've got your index into the image, which is our current pixel we're processing. We are converting that image into the palette value, right, for the NES, which is the one of the 64-bit possible colors. And then we have to get the RGB value from the NES palette, store it in pix, and we're good. And let me think about that. So that is, that converts that. Do we need to do anything else beyond that? Probably not. And all I really want to do is just draw that same thing here. So make sure image isn't null. What I probably also need to do is if image Tiger free image, and let's, okay. Yeah, I didn't expect that to do much of anything. So let's take a look at this. If I click on it, well, okay, if I click on it, I get the image has something, so I'm going to free it. loading my sprite. So current sprite now has some info in it. Right, it's got the image. It's got the, okay, so now I'm going to create the tiger bitmap. Got my total bytes. And I'm just going to iterate over. So let's see. So what did that do? That set. Yeah, so that I mean, current sprite dot image I. That's 1. And then current sprite palette 1 is that. And then GUI NES palette 42 is that. So that all looks reasonably good. Why is it not drawing? Oh, because I didn't actually set sprite selected to true. Well, that's stupid. Sprite selected equals true. Otherwise, sprite selected equals false. Hey, all right. So we've got our little sprite here. So now if I switch back, yeah, we got the full drawing here. If I create a sprite of that and I switch to that, let's see. Is it actually detecting the click properly? All right, so it's detecting the click properly. Is it not? Oh, image selected has to be turned off. Yes. So same thing. Okay, image selected equals false. You know, actually, thinking about it, yeah, I can probably do this when the list item, I mean, it shouldn't be possible for you to select multiple list items, technically. So you can just do that when something is selected. Okay, so getting there. It's now the controls are disabling, but it seems to not be. Let's see, so that's no, that's good. Oh, is it the image ID? Yes, the image ID is not changing, but we're also not setting the image changed, which is all important. Image changed equals true. I'm not crazy about having to do that. So what's interesting is actually the colors that are being displayed are slightly different than what the PNG is representing. It's almost as if, I don't know that they're wrong, they're just different. I wonder if the PNG palette is a less true representation of what the NES, I guess it would have to be. It's possible. So what's possibly happening, most likely what's happening actually, and I'm okay with this. I'm not going to be super particular about that. What's likely happening, or what I'm almost positive is happening, is the colors we're seeing here are coming from the PNG, and internally we're mapping the colors to the NES palette that we have here. When we create the sprite and we switch to the sprite is actually being drawn through reconstructing it from the colors that are in the palette, the NES palette, not the PNG palette. And I'm thinking that the palette I used in Photoshop is actually slightly different. So that's kind of an interesting artifact of this change. And if we go to, we loaded this into the shooter ROM and put the palette in too. Let's see, does that look more like, what looks more like what FCEUX is showing? Hard to say. I feel like this is probably closer to this. I wonder if I just need to update my palette. I'll probably end up making it so the palette is replaceable. I don't want to do that tonight just because it's not really critical, but as I've mentioned before, the palettes aren't exact. The original NES palette is, you know, composed of analog signals, and so there's a lot of debate over what's an accurate representation of color. For now, let's be satisfied with the fact that we're loading this from the sprite file, and now we need to render the palette underneath here based on the loaded. And actually, if you flip back and forth quickly enough, you can see that the palette that's being drawn here, this green doesn't really match that green, but it does more closely match that green. So I'm pretty sure that's what it is. So if we let's draw that same palette control here. We can actually pretty much mirror this. I don't care about the color exceeded because the color shouldn't be exceeded from, in terms of the from the perspective of a sprite being selected, because it shouldn't, I mean, we've already processed it. It shouldn't be generating sprites that are invalid. That button can go away. We do want the palette view, but the palette is now coming from the current sprite. Okay, cool. So we're actually getting, oh, interesting. So that's a holdover of the fact that the palette is not fully initialized in this particular instance, because this is only using 3 colors. If I go to this and then I flip to that, you can see that color is the same. If I go to the ship, it's blue. If I go back to the flyby, it's now blue again. That is probably just sloppy is the best way to describe it. So what we can do to fix that is let's zero out the palette. Right, is that, what is that? Yeah. So now we're just zeroing out that palette, so if it's not set, it's going to be a 0 value. I didn't think that that was going to... Let's see. Yeah, so now the flyby has a value of 0 in it, which gives you that dark gray color, which is a more accurate representation. Okay, so cool. So that's good. So that's all working insofar as that goes. Now I want to draw the bounding box or the bounding boxes if there are multiple. So let's do that. Let's so this is going to be a rectangular control of some sort. So let's start with simple rectangular controls, and let's just say GUI bounding box. I think it's okay to call it that because that's really all it's going to be used for. So current sprite number bounding boxes. Rules Warren, sorry. if you want to talk to me about the sharing classes thing, why don't you direct message me on Twitter? We can talk about that. I saw you need to go to sleep, so why don't you do that, and then we can talk about it some more. Let's just say that this is going to be the X5 5000 range, just for kicks. So we got a bounding box. We've got to put an X and Y coordinate for the start, and then the current sprite bounding box is I. So that's going to be our, well, actually that should be a pointer to, yeah. Okay. So we'll do this like we do with all the rest of them, where we have, let's see, right now I'm not going to add any controls to anything or any return value to this. I just wanted to draw the bounding boxes. So so then we have our X, Y, so vector 2, I'm gonna have to move that into the helpers because it doesn't know, it's not going to know what that is. Vector 2 pointer, bounding box, same thing with size of bounding box, so let's do that. Bounding box size, rather, I should say. So in helper CPP, we put the structure definition. Is that not going to be a problem? I don't remember. It's been a while since I've done that. So let's just put this all into the header file. I think it's going to complain about structure redefinition, but we'll see. GUI, so vector 2, let's compile. More than one matches. Yeah, so syntax error identifier vector 2. This doesn't have. So this is, actually do this. And that, maybe we'll get away with it because we're not doing. We're doing a Unity build here. So, come on, exclude from build. Damn it. Compiled, that's a little scary. All right, let's. So I'm gonna get rid of this because this is actually no longer needed at all. It's just adding content to where it's not needed. All right, so bounding box, we're gonna do what we always do: control node, find set active, ID. right? Oh, current context ID. If not node, we need to create it. X and Y, and the bounding box width and height, we gotta calculate that. And there's no anchor information at the moment. So int width is equal to bounding box let's see, the width would be this X, which would be the top left corner. So the way that we're storing this matters, because let's see, because otherwise you can't, the calculation for the width and height will be wrong of the bounding box itself. So when we write the sprite, we are doing let's draw this out. We are saying, okay, this is, so 0 is the top left, and then 1 is the top right, right? If this is our box. And then this is 2, and that's 3. So that's simple enough. So back in the GUI stuff, we're going to say, so this should actually be X equals bounding box 0, X not equals minus. Come on. And for height, it is going to be, you can just use 2 and 0. That'll give us our width and height, right? And bounding box might not be the best name. It might be better to do something like selectable rectangle or something like that. But for something like this, this is pretty specific to this UI. Right, so that's the control type, and then the renderer is render bounding box, right? I don't think there's anything special we need to do right now, because I just want to render a rectangle when we get called. So render bounding box tiger layer, control node. And it's just literally going to be tiger rectangle to layer node X, node Y, node, and then color. I guess at some point we'll be able to change that, but let's just say red. Let's put a constant for red. So that is our red. Oh, this should be width and height first. Node. And then I probably want to put little control selector rectangles like you would expect in, like a, like if you've ever used Photoshop or something like that, where you've got the, what is it called? The selection box, right? Or the transform, right? The transform will have little control points on it. So there's one for each corner, and then one in the centers of each position. And these are actually going to be affixed. I should have done that first. So 2 through 4, 1, 2, 3, 4. Those are our control nodes. So, and then they're going to be at, let's see. So that'll be at x minus 2, because we're going to offset it by the width of the little control node size. Actually, well, if it's 4, actually we want to do 8. Let me stop doing that. So let's see, right? Because if it's 8, what we want to do is we want to offset it. Wait, if it's 8, when we offset it by 2, then no, it should be 4. I was right the first time. Because we're dividing, if we want to center it, we divide by half and then subtract by that half value. So that's fine. So that's our that's our top left, and then our top right is the node plus the node width. Yeah, good work. Right, so that's going to be our top right. And then we'll do our bottom right. And then our bottom left. Let's just make sure that these are working as expected before we do the other control points. So bounding box, I just got to add it to the current context because I'm not doing that. So add control node, current context node, and we don't need to do anything else right now because we're not doing any checking for selection or resizing or anything like that. Oh, right, but we're also scaling by 4. Okay, well, so that the good thing is that that looks pretty decent. The reason it's so tiny is because we're actually scaling the image times 4. We'll make that scale be a value that we store, not times 4. That's hard coding it, which is not what I want to do. And then what we'll say is bounding box data dot scale equals scale, and let's add right. Okay, so that's that, and then we're going to add it here to our union. Okay. Bounding box. So we're good. We got the scale set. I guess we don't want to. You know what? I'm gonna change this because I don't want to. I don't want the width and the height to actually reflect this. What I'll do is similar to what I've done in a couple of the other things where I'll have a display value that applies. Where did that go? Okay, so into display width, into display height, and that'll be the width and the height times the scale. So and then we'll just use that when we're actually drawing this. I don't really indexing into that here. So that's width, and that's width, and that's height, that's height, and well, actually, that's not going to work because we have to pass the scale to our bounding box. And it's 32. No, it's not 32, it's 16 and 16. Oh. All right, almost there. Just a slight slight mishap here with the yeah, that'll work now. Cool. So that's fine. We know that the bounding box is going to be too big, obviously, because it's, you know, hard coded to be literally the dimensions of the thing we're looking at. So why doesn't it resize? Is it the same thing as these? Okay. Yeah, it's just because I'm switching between and it's not refreshing. I gotta figure out a better way to handle that. I'm gonna have to think about that because it shouldn't be doing what it's doing here, where I need to be updating a flag to tell it to refresh the control because the ID didn't change. That's kind of dumb. I also want to make those control points a little bit bigger, maybe. So I make them 6. And then I think I'm going to wrap this up because I am pretty exhausted right now. It was a long day. Fun day, because I wasn't at work. I was actually out doing some stuff, but still a long day. Sometimes when you take a day off, it's more tiring than actually working. Okay, so that looks a little bit better. Why? Let's see, if this is 0 and we're getting -3, -3, and we add 6, yeah, that should be okay. Wonder if I'm just being super picky about the way that looks. I feel like this is not overlapping enough the way I would expect it to. But anyway, the control points are displaying. So let's do the other control points now, which are going to essentially be at the midway points, right? So it's going to be, this one should be at the plus node x, no, just width divided by 2, right? And then, curious to see, it's not gonna, oh, because I didn't do it in a breakpoint. Oh, okay. That's fine. That's that for the top middle one, and then for the right middle one, it is this plus node width divided by 2. Or node height divided by 2, I mean. Cool. So those are the 2 control points that I added there. I didn't mean to full screen that. Okay. And now I need to do the bottom one, so it's just basically this with the full height added to the Y. And then for this one, it's this, oops, but without the width added to the X. Right, I'm just moving things around to make the points draw. Yep, so that's cool. That's what I expect. What we can do that'll be even cooler is what we can do, let's manually change the bounding boxes. So what I want to do is I want to say, okay, that bounding box is way too big. I'd like to be able to shrink it. Eventually we'll be able to do it with the mouse, but I just want to test out that this isn't going to draw the way that I expect it to. So let's, we should probably add a little mouse control that shows where the mouse coordinate is, maybe in the image, but that aside, let's guess. If this is a 16 by 32, then halfway is going to be 8. And I want, so the Y value for the bounding box shouldn't be less than 8. So let's say this is 8 here, oops, and 8 here. And if we reload that, did I mess that up? I definitely messed it up. I don't know why I'm asking if I messed it up. What did I mess up? So this is our 256 bytes, right? And then our 2 pointers, and then 512 bytes of data. Oh, which means the bounding boxes start here. Oh, because, wait, are they, but they're shorts, aren't they? Should be. They're too shorts, but okay. I guess I'm just, like I said, I'm tired. I'm messing things up now because I'm tired. So here, quick fix is let's recreate the sprite. Why? It's not overwriting the sprite. There we go. I guess it couldn't write it. I gotta add some better error detection, I guess. Alright, so here's our sprite again. Here's our bounding box. So here is what should be the first point. This is not working the way I expected it to. Let's do this. So that's 0, 0. That's 0, 0. That's 16. Oh, yeah, dummy. Okay. Sorry. This is the X. This is the Y. This is the X. This is the Y. So now that should shift this down. No? Wow, I should just give up. I clearly am messing things up. Oh, right, it's not the value you think it is. Okay, so because of the byte order that we're dealing with, I actually want, so this is I was right in terms of the shorts I was writing to, I was writing it in the wrong value. in the wrong byte in the set. So it should be that one. And okay, so that did change it. It's not drawing a polygon, so me changing it to be something that's not an actual rectangle is not going to affect the way it determines the points. When it draws, it's just drawing a rectangle, not an arbitrary polygon. So what I'm saying is, like, because I did move the y coordinate up to 8, at least, yeah. So because I moved the x coordinate to 8 in one corner of the bounding box, because it's a bounding box, it's not a bounding polygon, it didn't skew this to show both had changed. It just showed that I guess that means that I really don't need to be doing what I'm doing with the 4 points. I probably could get away with just having the x, y, width, and height. I'm just gonna change it to that, because otherwise it's unnecessary to have that information. So that's the x, and then that's the y, which is 32. So we want to take away 32 minus 8 is going to be 24, but what is that in hex? That's 18. Did I say 18? 18. I don't like doing hex math in my head. It just, I mean, not again that I can't. It's just, especially when I'm tired like this, just screw things up. I've already, something's not working right here. I think, again, it has to do with the way that the bounding boxes are being calculated, given that it's a bounding box that is representing a polygon, even though it can't be a polygon. Let's fix that. So let's see. So this actually only needs to be 2, because it only needs to be the x, y, and then the width and the height, right? So let's fix that real quick. Because we can calculate the other coordinates that we're checking based on the width and the height. We don't need to store those explicitly. So 0, 0, and then image width and height. Those go away. That's fine. And then the GUI, when it is calculating its stuff, it doesn't even need to do, the width and the height are already stored in here, right? And then we've got our display width and height, and then render bounding box. We've got our display width and height here. I think that might be ultimately simpler. So let's recreate this. And then reopen this file. Okay, it's shorter. That's good. That's our x. We have our x and y here. So I want the x and y to start at a different location. I want the x, let's say, to start at 4. I want the y to start at 8. And then we'll leave the bounding box size the same, just to show that it actually skews. Come on, y. That's so weird that that's not loading. Again, it's the same problem I was seeing before with it being... It's because the control ID doesn't change, so it's not recreating the item with when you switch between sprites. It's just using whatever was loaded, which isn't correct. You have to switch like this between PNG and sprite. So that is okay. So why is the X and Y? Oh, okay, because I'm not actually using that, which is not helpful. So the X and Y that I'm passing in should actually be offset by, that's why, bounding box 0x and bounding box 0y. Right, because if you're not doing that, it's not going to actually shift it the way it's supposed to. Okay, so and then of course that needs to be scaled as well. Let's see, plus this times scale. Times scale. And I know that multiplication has precedence, but I like to be really explicit about that just so I don't screw it up. All right, there we go. So now we've got this working. So I've got this at, let's see, so I've got that at 8 by 8, which is too small. Obviously, we can make it 8 by 16 maybe, right? If I save that and switch back, now the bounding box has increased, so it's double the size. We may say, you know what, that's a little bit too, it's a little bit too low. Let's make that 7. Okay, and that's all shifting the way that I want. So that's cool. So that actually looks like a reasonable bounding box. And then what we'll do is we'll make it so that you can click on these control points in the next stream, because I'm just totally done. I'm just not in my usual frame of mind for it today. We'll be able to click on this and modify the bounding box by clicking and dragging it, maybe add additional bounding boxes, and then also save the sprite. We can add the buttons we need pretty easily. I'm sorry that this stream was kind of a slow one today. Just wasn't I don't know, wasn't feeling it the same way I usually am, but regardless, hopefully that was some good progress, and you know, we'll get back to it on Thursday. As always, if you need to, you can rewatch these on YouTube. They're recorded and posted almost immediately after the stream. You can reach me at Clairvis on Twitter. You can find me on Nintendo Age. In the Discord chat primarily, although I'm on the forums as well, and a whole bunch of other really excellent, smart, nice people on Nintendo Age and Nestev. So yeah, thanks to those who watched, and I will see you next time.